Geometry of dynamic tetrahelix and field structures. Part 6. The tetrahedral field structure will be introduced and its potential use as a field structure model will be discussed. Part 6. Tetrahedral Field Structure, TFS. Another interesting structure, with similar properties to that of the structure defined in field structure theory. This structure was found within the matrix of the modified tetrahelix system. This structure will be referred to as a tetrahedral field structure, TFS, and can be constructed as a modified tetrahelix. Construction of the tetrahedral field structure, TFS. This is a physical model of the TFS, which is constructed as a single loop with this 36-bit subsequence as seen here. At the center of the TFS is the tetrahedral structure located at the voids created by the matrix of CFS. The tetrahedral structure is an integral part of the matrix. There are several different modified tetrahelix subcomponents that can be bonded together to create the TFS. Single loop TFS. The TFS can also be constructed in the simulator as a single-loop modified tetrahelix using the 36-bit subsequence as seen here. This video shows an illustration of this TFS. Multi-loop TFS construction. The TFS can also be constructed from 6 smaller subcomponents, a 6-arc loop. The 6 is a modified tetrahelix with a subsequence of 1, 5, repeated 3 times. This subcomponent is a very stable structure and is also a basic subcomponent of the 4-loop CFS. Multi-loop TFS construction. The TFS can also be constructed from 3 smaller subcomponents, a 12-arc loop. The 12-arc loop is a modified tetrahelix, the subsequence of 5, 5, 1, 5, 1, 3, 3, 1, 5, 1, 5, 5. The next video shows the physical construction of a 3-loop TFS that doesn't require any cutting and reconnecting of the loops. 3-loop tetrahedral field structure construction. This video shows 3 of these TFS subcomponents grouped together. They will be separated into the separate subcomponents and will be used to build the tetrahedral field structure, TFS. The 3 subcomponents can be aligned and there will be a natural alignment of their arcs because they are all constrained to the matrix of the modified tetrahelix system. The subcomponents connect by adjacency and don't require any cutting or reconnecting of the loops to form the TFS. The TFS, with membranes and tubes. In this example, the field intensity of the TFS can be increased by adding additional parallel arcs. The additional arcs create membranes and tubes that add an extra dimension to the TFS. Bonding between TFS. The TFS can be easily bonded together by interleaving their vertices without breaking and reconnecting the loops. When the vertices of the TFS are interleaved, the arcs have a natural alignment within the matrix that forms the bond. The top vertex of the TFS can be arranged in a clockwise or counterclockwise manner and as a result can be bonded in 2 different ways. Bonding between 2 similar TFS and bonding between 2 opposite TFS. The resulting superstructure, double TFS, creates 2 enclosed tetrahedral structures. Bonding between opposite TFS. The 2 different TFS in this video have their vertex arranged in different directions, and this will demonstrate the bond between 2 different TFS. The top vertices of the TFS are aligned and merged together and have a natural alignment within the matrix of the modified tetrahelix system. The merger of these 2 TFS creates a superstructure that contains 2 tetrahedral structures. Bonding between similar TFS. The two different TFS in this video have their vertex arranged in the same direction, and this will demonstrate the bond between two similar TFS. The top vertices of the TFS are aligned and merged together and have a natural alignment within the matrix of the modified tetrahelix system. The merger of these two TFS creates a superstructure that contains two tetrahedral structures. Double TFS comparison. Let's compare the two different double TFS created in the previous videos. The structure on the left was created with two similar TFS and has only 3 lobes that surround the center of the structure. The structure on the right was created with two different TFS and has 6 lobes that surround the center of the structure. Additional modified tetrahelix examples. This video illustrates some examples of other modified tetrahelix, defined with a different subsequence. The arcs of all these modified tetrahelix are constrained within the matrix of CFS and form closed loops. Note that these structures could also be used as subcomponents and bonded in various ways to create more complex structures.